Okay, just giving it a second so that it starts. Welcome, everybody, to the Synergetics live stream. This is Synergetics live stream number 8. All right, looks like we're on. So you can leave a message in the live chat if you're watching it live, or you can leave a comment later. This is Synergetics live stream. It's Synergetics live stream number 8, and I'm trying some new tools as far as live captioning. It's May 30th, 2021. I'm Daniel. The spirit for today, starting with just usually 3 terms, are play, dream, and transpose. So we'll see how those come into play in what we're going to do right now. In 8.0 right now, we're going to go through the key memes and themes and some future things to integrate as usual. And then we're going to go to 3 sections of Synergetics. But today there's also a few other slides on William Blake because it was interesting. And the sections we're going to go through are 240, Synergetics Corollaries, 608, Stability Necklace, and then 630 through 633, Anti-tetrahedron, Dynamic Symmetry of the Tetrahedron, Negative Tetrahedron. So for those who are listening to their first or thinking about their first Synergetics material, Synergetics at a large overview, and others with different and more experience can feel free to add what they think Synergetics is too. It's relational and multi-scale thinking. It's connected to accessible experiences. It doesn't have infinitesimals or points or lines or planes, which we're going to get to in the first section of the text. It frames design as an anticipatory cybernetic science, somewhere between engineering and innovation and math and all these other things. And the relationship broadly between tensegrity and synergetics is kind of like between engineering and physics. So tensegrity has to do with structures and usually physical things and buildings, which we'll get to later. But synergetics is the more abstracted version, just like physics is. And we find out, and we'll talk about, that space has a shape, and that this idea of structure as pattern and pattern integrity comes up again and again, and there's dynamic and there's static structures. Universe is the total scenario, and you don't need to sub-specify the universe because it's the whole thing. And then system is any specified system, and one thing we're going to talk about today is that the tetrahedron is the minimal system. And then the idea of 4D comes up. Here's Kirby's awesome videos, a screenshot showing several namespaces for 4D from geometry and from physics, and then kind of Bucky's own synergetics use. And there's other uses of 4, and then I think 4 will come up a lot today. Okay, so nothing has changed too much here on the things to integrate. Some general questions that we're still curious about, a few sections that we won't get to today. But as sort of a interlude before the Bucky, preparing for the section on 630 to 633, I was reminded of William Blake's concept and differences between negations and contradictions. So there's another stream with more about Blake and Bucky, but this is just a few interesting points that is also kind of consistent with how Kirby and others frame it, showing a humanities origin and home for synergetics with a mathematical layer that builds on it, potentially, but we'll see about that. So here is from the poem Jerusalem by Blake. Negations are not contraries. Contraries mutually exist, but negations exist not. Exceptions and objections and unbeliefs exist not, nor shall they ever be organized forever and ever. All right, so in these early lines, Blake is distinguishing between the negation and the contrary. And the contrary are like two things that exist in tension, like tension and compression in tensegrity, and the negations are non-existent. So there's more poem and things to read there, but it's just going to come into play because we're going to talk about negative tetrahedra and then anti-tetrahedra. So isn't the anti of a number the negative? Well, there is, but there's also another way to resolve that tension of tensions. Another section of Blake is from the Marriage of Heaven and Hell, where it's written, without contraries, there's no progression. Attraction and repulsion, reason and energy, love and hate are necessary to human existence. So, as opposed to more formal logical efforts that would be only able to oppose claims, there's some papers that were arguing that Blake moved the realm of logic towards like an emotional and an archetypal by opposing just words or concepts. And then a famous memeable Blake line, do what you will, this world's a fiction and is made up of contradiction. And so it's not made of negations, it's made of contradictions. This Prather 2007 paper was called William Blake and the Problem of Progression. And in that paper, in the abstract, it reads, the paper begins by considering Blake's appropriation of the term contraries and its limitations in The Marriage of Heaven and Hell. It then focuses on a short passage at the beginning of the Four Zoas that extends the marriage twofold conception of contraries into fourfold complement of contraries and subcontraries. Four possibilities that the passage, disregarding basic rules of logic, synergetically embraces. And then those early lines of the Four Zoas, which is another Blake work, is, four mighty ones are in every man, a perfect unity, cannot exist but from the universal brotherhood of Eden, the universal man, to whom be glory evermore. Amen. So, here is one of the figures from the paper that is kind of parsing these lines in a logical framework, expanding logic kind of beyond formal claims, almost moving it into the realm of graphical argumentation, thinking about how these different terms or beliefs might be opposed to each other, and how there are some that are perfectly contradicted, which is the X in the middle of these four claims. Everyone is a perfect unity, no one is a perfect unity, someone is and someone is not. All these claims are related to each other, or they're of different types of relations. So this is kind of like argument mapping or rhetoric analysis in approaching a computational way. And then here in this table are different logical framings of that qualitative relationship. And then on the right, using imagery that would have been natural to Blake, there are related different characters, Urizen, Orthona, Liva, and Dharmas, who have different logical relationships to each other and different relationships highlighted in the text. So that was kind of interesting. And then just to close on this, 3 sections about this topic, the idea of a tetralemma. So a tetralemma with respect to a logical proposition X is these 4 claims: affirmation, negation, both, or neither. So there's a few different representations. This on the top left is a sort of cross-based form, similar to the previous Blake illustration, that shows how you can have, both, one or the other, or neither. Then there's uses of this idea that are more related to Peircean semiosis. So here was one example that was online of how the Peircean notions and some formal logic in that space was related to a tetralemma of what was possible in semiosis. And then here was a tetralemma with blockchain. So on the left is the well-known crypto trilemma, which is decentralization, scalability, and security. It's sort of like, fast, cheap, and healthy, choose 2. And then there's a fourth point added with on-chain settlement time in this example. But different features could be imagined. And so how do we move into a higher dimension of problem solving to find a better shape of the system that we want to design, a more adaptive shape. There's many choices for what the vertices are, and so we'd want something that could apply not just to these four terms, but that could apply to any tetrahedra and allow people to compare tetrahedra. So in the then one last way that the tetralemma was used, it shows that there's position A and position B, and then there's an oscillation between the two of them reaching a green hexagon that says both. And then that is sort of the Hegelian jump to none of both, and then a hinted fifth position. Just a graphic online. Reading more about that, though, led to the term Cadu-Scotti, which I would love to learn more about if anyone's familiar with it. But it says on the Wikipedia, it is a logical argument of a suite of four discrete functions of, or an indivisible quaterny that has multiple applications and has been important in the Dharmic traditions of Indian logic, the Buddhist logico-epistemological traditions, particularly those of the Madhyamaka school, and in the skeptical philosophy of Pyrrhonism. In particular, the Cadu-Scotti is a four-cornered system of argumentation that involves the systematic examination of each of the four possibilities of a proposition P. So that was this minimal tetralemmal logic of these four claims. So there's your minimal atomic argument claim. And then later in the page, it says, Sunyata is the ninth view, the viewless view, a superposition of the 8 possible arrays of proposition P and its inseparable contradistinction. So even from this Prather paper, here was a figure. The two tets were juxtaposed with the positive configuration of the claim, for example, of eternal life being true, versus a negative configuration with eternal life being false. And, or that is on a contradiction, so an opposite, not a negation, with death. Because if eternal life is false, then death is true. But if eternal life is true, then death is false. So, pretty cool stuff. And interesting that Blake was working in this way. All right, so we'll see where that comes into play in the text. First, we'll go to 240, Synergetics Corollaries, up to maybe 33. The first one, universe is finite. That was one of the main memes and themes, because you don't need the universe, you just say universe, and that's when you're making a claim that's related to total scope, versus any subsystem is going to require certain ways of modeling it that include what's on the outside of it. Local systems are finite, they are defined, and they are finite. So if universe, whatever it is, putting that one aside, which is its own special terminology, number one, then any local system needs to be defined and worked with in a certain way, or at least could be. 3, unity is complex and at minimum 2. So people have a lot of different interpretations on this sort of thought, and it's worked throughout the text a lot. It's the idea that unity implies more than one kind of thing coming together. So nothing from nothing, or you can't just have one type of thing and then declare it a unity, because it's not in a space where that could even occur. So unity has to be at least 2. 4, appropriately. The tetrahedron is the lowest common rational denominator of universe. The 4 unique quantum numbers of each and every fundamental particle are the 4 unique and minimum stars of every tetrahedron. So before you get 4 points in constellation, whatever those 4 things are, you don't have an enclosed space. And maybe today this might be framed as saying you want to have something that's scale free. or that describes multi-scale systems, you want to have something that can describe small things and big things, because then they can be compared and maybe even composed. So it's kind of interesting. He calls it a particle right off the bat, just like Carl Friston's particular physics, which is a fourfold distinction. 5. A point is a tetrahedron of negligible altitude and base dimensions. So point is relative to the modeler, and it refers to just a tetrahedron whose size you can't resolve. And Bucky's example on that is about zooming in on the chalk on a chalkboard and just seeing a little granule, and that's a point, but you don't need to introduce an infinitesimal because you know that it's finite. So you can say it's really tiny and I had to magnify it so and so many times to see it, but still it has to be finite because local systems are definite too. 6. A line or trajectory is a tetrahedron of negligible base dimension and significant altitude. And so that is shown with like a unrolling of a tetrahedron that's very, very long on a trajectory relative to its width. So it's like 1 inch across and then it rolls across a whole continent. So if you zoomed out and saw it from space, it would be like 1 pixel on your measuring device. So it would appear like a line. And so a line is indistinguishable from another alternative when it's just really far away. So it's almost like these geometrical concepts are being defined in the limit of the observer rather than as fundamentals. That's why he's still calling them quotes. 7. A plane or opening is a tetrahedron of negligible altitude and significant base dimensionality. So like graphene is 1 layer thick. It's not infinitely thin. So anything that has molecules is going to be at least 1 layer thin. And so that's like a plane from the perspective of a modeler maybe, but still it's something that has a z dimension. 8. There are no solids or particles, no things. So if it's going to exist, it has to be a thing, which means it has to be by these rules. 9. A point is an as yet undifferentiated focal star embracing a complex of local events. So star maybe here is being used not just to refer to the sun and other kinds of celestial bodies, but it's referring to, for example, an atom, which is still, maybe it can be treated like a point, but it is a complex of local events reflecting the two kinds of multiple things happening in the nucleus and multiple things happening outside of the nucleus, just to be general. 10. There are no indivisible points. So that relates to the definiteness, is all points can be broken down from, I think, probably the level of the modeler. Not sure about that though. 11. Unities may be treated as complex star points. Again, using a star in a different way than the sky version. So we'll keep an eye out and wonder what star might be referring to. 12. For every point in universe, there are 6 uniquely and exclusively operating vectors. That's going to come back to the 6 edges of the tet, because there are 6 vectors that come into existence when the space is enclosed all at once. You have 5 vectors that can't be linked up in a space-filling way. 13. Vectors are size. No vectors equals no size. No size equals no vectors. So this is a suggestion that when the abstract system comes into existence, it's kind of one-to-one with the physical systems. Like things don't exist physically unless they're under this way of being described, maybe. 14. The size of a vector is its overall wavelinear length. The overall wavelength is kind of related to the different frequencies of energy, Wi-Fi and shorter wavelength than radio, but that's just something interesting to keep in mind. 15, there are 6 vectors or none. That's related to the tet coming into existence and just the number of minimal descriptors for something that's going to physically exist. 16, every event has size. So the pattern is general, but the size is specific. So that's kind of like a shape. The angles are conserved even as the shape scales up and down. But for every d finite event, every system of complex interacting things, there has to be a size to it because there has to be a specific realization of it. So then it can't be having a specific realization, but also outside of the rules of the space having a shape. Every event is 6 vectored. Again, could be like the 6 edges of the tetrahedron, like 18. 6 unique vectors constitute a tetrahedral event. That's almost a triple repetition of the same thing because 6 unique vectors constitute a tetrahedron. And the event is the minimal happening. So it is tetrahedral because every event is 6 vectored and has a specific size. So the size part is the specifics, and the 6 vectoredness can be thought of as the abstractable. 19, every vector is reversible, having its negative alternate. That's kind of that contrary and negation. What is the negative alternate? It's like the arrow going the other way in the other way. 20, all lines, still scare quotes, all lines, trajectories are the most economic vectorial interrelationships of non-simultaneous but approximately concurrent local event foci. Little bit harder to parse, but there's a few ways of thinking about it. In physical terms, it's almost like if you shake somewhere on a geodesic dome, on a tensegrity structure, the force is going to be dissipated, or the information is going to be propagated through the least energy, the least free energy sort of modes of the system. So the structure of the system, which is to say those lines that connect events, though the structure of that system is kind of how it's existing, because it's in an existence metastable energetic position. Otherwise, it doesn't have existence. Maybe. 21. Potentially straight line relationships require instantaneity or actions in no time. Therefore, straight lines are non-demonstrable. Think about the edge as taking a little bit longer, but happening on the geodesic that space is actually on, but I'm not sure about what it means. 22. The overall longitudinal length of wavelinear vectorial lines is determined by the number of waves contained. So that might be like saying, if you're in a 10 meter per peak to trough radio wave, then the overall length of the line is related to how many physical repetitions, or it could be 3 times stronger if it's faster wavelength. I wonder how this part lines up with how the kind of signal processing people think about this. Like 23. The number of waves longitudinally accomplished in a given time constitutes frequency. So maybe that's how many peaks and troughs occur within a given time interval passing by an observer. 24. Physics has never made an experimentally demonstrable discovery of a straight line. Physics has found only waves and frequency, i.e. angle and frequency modulation. So in other words, everything's kind of going at the same speed, which is to say it's a finite speed, but the angle and the frequency of things can be changed. And a laser looks straight just to an observer, but then we know that it's a question of scale, and if you moved in, maybe there's something a little bit different happening. So I'm curious what main, people in physics think about straight lines existing. 25. There are no straight lines, physical or metaphysical. There are only geodesic, i.e. most economical interrelationships or vectors. So it's kind of a usage of geodesic that's not architectural. It's referring to geodesic as the surface that contains the most economical dissipations of force or propagations of information given the structure of the vectors. So that's kind of a cool notion of geodesic. 26. All lines, trajectories are complexly curved. And 27. Vectorial lines or trajectories are always the most economical event interrelationships, ergo geodesic. So it's something to keep in mind even when we're looking at a static wireframe, that those are relations that can be dynamic. Now, in a physical structure like a tensegrity structure, they might be at an equilibrium that's static, like this. But if these are ideas or sources of statistical variation, then maybe the edges are a little bit dynamic. And the geodesic is just this sort of defined trajectory space that reflects how in existing systems they're kind of pursuing the free energy minimization. Or maybe it's related to a different concept. Every point, 28, event embryo, may articulate any one of its 4 event vector sets, each consisting of 6 positive and 6 negative vectors, but only one set may be operative at any one time. Its alternate sets are momentarily only potential. So this could be related to the flipping of phase, where one set is real and one is in the imaginary space, or one set is asleep and one is awake, sort of biphasic systems and 2-mode systems. 29. Potential lines are only inscrutably non-straight. All physically realized relationships are geodesic and wavelinear. So this is kind of about making the R maps reflect some things that we know about the territory, such as the working corollary or axiom or whatever you want to call these, that energy is wavelinear and that structures have finite size even at the smallest level of their events, and that events happen on geodesics. So now we're going to take those observations and then adapt our axioms. 30. Two energy event trajectories or lines cannot go through the same point at the same time. So that's probably a difference from just geometry modeling, where you could say, oh yes, 3 lines intersect through this point and then they continue off in their own infinite direction. So here they exclude each other because only one energy event can be in a place or not at a given time. 31. All geodesic lines, trajectories, weave 4-dimensionality amongst one another without ever touching one another. Maybe how photons sort of dance along in a stream, or gliders in the game of life. Not quite sure what that means. One other area it could be related to is if you have a random walk variable on a number line, it always is going to kind of pass by some point with given enough time. But in a 2-dimensional space, the odds of it getting within a ratio or within a small amount of a target space go down. So maybe in the 4th dimension, there's enough room for every trajectory. 32. It takes a minimum of 6 interweaving trajectories to isolate insideness from outsideness, ergo to divide all universe systematically into 2 parts, macrocosm and microcosm. Because the special event that happens when you get 4 points is you make inside and out, which is the only reference point, because up and down are just all a perspective. And inside and outside is 2, but it's one that can be grounded in a different way. 33. A 6 trajectory isolation of insideness and outsideness has 4 interweaving vertices on prime convergences of the trajectories, and 4 areal subdivisions of its isolation system, and constitutes a tetrahedron. So when you have 6 vectors, you get insideness and outsideness, you get 4 interweaving vertexes, or harmonic modes of the trajectories. And you get 4 areal subdivisions, so faces, of the isolation system, 4 faces of the tetrahedron. So that is 240. Next section is 608. So this is called stability necklace. So this is going to be another style of argument for tet. The last section was kind of tet by fiat, fiat tet, tet lux, and it just went from a minimal systems argument, space enclosing implicitly, for the tet. Now there's going to be a hands-on structural tet rationale. So 2. A necklace is unstable. The beads of a necklace may be superficially dissimilar, but they all have similar tubes running through them, with a closed tension string leading through all the tubes. The simplest necklace would be one made only of externally undecorated tubes and of tubes all the same length. As the overall shape of the necklace changes to any and all polygonal shapes and wavy drapings, we discovered that the length of the beads in a necklace does not change. Only the angles between the tubes change. Therefore, stable refers only to angular invariability. So, when you're working with beads on a string or physical granules of chalk, some minimal level of even particular or conical arrangement, because a conical implies that there's probably smaller particles, unless it's a cone or whatever at the bottom. So you're going to be having the edges are like your actual bones. So those are the parts that are not going to change as a function of stability, barring a catastrophic rupture event, which implies that there was a lower level of stability. So we're kind of getting all the way down or just thinking about it without that catastrophic element. So stability is angular. Stability is an angular phenomena, not related to rupture fundamentally. And then if angular stability breaks down at a given level of structure, it can lead to structural rupture at a different scale of analysis. 3. A 6-edged polygon is unstable. It forms a drapable necklace. That's this hexagon on a plane. If we make a 5-sided polygon, i.e. a pentagonal necklace, it is unstable too. It is too a drapable necklace and is structurally unstable. Why? A necklace of 3 rigid tubes also has 3 flexible, angle-accommodating tension joints. Here are 6 separate parts, each with its unique behavior characteristics, which self-interfere to produce a stable pattern. How and why? So that is the structural stability of the triangle. So that's 3 connected nodes. They restrict each other's motion in a way where all of a sudden they can resist laterally and be stable. How and why? We are familiar with the principle of lever advantage gained per length of lever arm from the fulcrum. We are familiar with the principle of shears in which 2 levers share a common fulcrum. And the stronger and longer the shearer arms, the more powerfully do they cut. Steel bolt cutters have long lever arms. So this is like saying that the sweep out of what's possible, given the fixed edge length, the sweep out of each point is balanced. So it's resisting getting swept out or getting pushed in, because the edges physically resist, but also the angles resist when you try to collapse it in. And then when you pull it out, it's going even more against its desire to not have rupture. But this is sort of like shape stability questions. 3. In every triangle, each corner angle tension connector serves as the common interfulcrum of the 2 push-pull rigid lever arms comprising 2 of the 3 sides of the triangle, adjacent to their respectively common angular corners. So this is going to be kind of like side angle side, side angle type stuff. Each pair of the triangle's tubular necklace sides, in respect to a given corner of the triangle, represent levers whose maximum advantage ends are seized by the two ends of the third, rigid, push-pull, tubular side of the triangle, whose rigidity is imposed by its command of the two lever arms ends upon the otherwise inflexible opposite angle. So the angle resists changing because the strut opposite it resists changing. Thus, we find that each of the necklace's triangular rigid tube sides stabilize its opposite angle with minimum effort by controlling the ends of the two levers fulcrumed by that opposite tension fastening of the triangle. Thus, we find the triangle to be not only the unique pattern self-stabilizing multi-energy complex, but also accomplishing pattern stabilization at minimum effort, which behavior coincides with science's discovery of the omni-minimum effort behavior of all physical universe. So it's kind of like a thermodynamic argument for structural stability. Even if you could do structure another way, and you can't, because we know the square can be kind of pushed around into a parallelogram, the triangle would be the more efficient way to do it. So free energy minimization, go for it. 4. The six independent energy units of the triangle that interact to produce pattern stability are the only plural polygon surrounding energy event complexes to produce stabilized patterns. The necklace corners can be fastened together with 3 separate tension connectors instead of by the string running all the way through the tubes, wherefore the 3 rigid tubes and the 3 flexible tension connectors are 6 unique independent energy events. So this could be describing 2 ways of making a tet with a necklace. You could have the tubes, 6 tubes, like 6 pipes, with a string running through them. Or you could have 3 edges that are then tensioned together. So that would give you sort of a duality of 3s, which is related to the zigzag breakdown of the kind of chirality decomposition of a tetrahedron. 5. We may say that structure is a self-stabilizing pattern integrity complex. Only the triangle produces structure, and structure means only triangle, and vice versa. Nice. Good shout out for triangles. So if the triangle is the nature of structure or the shape of structure, then even in other designs, you see the triangle emerging, like cross bracing in a rectangular house. I mean, why not just make it based upon a triangular structural unit? 6. Since tension and compression always and only coexist, see section 640, with first one at high tide and the other at low tide, and then vice versa, the necklace tubes are rigid with compression at visible high tide and tension at invisible low tide, and each of the tension connectors has compression at invisible low tide and tension at visible high tide. Ergo, each triangle has both a positive and a negative triangle, congruently coexistent, and each visible triangle is 2 triangles, one visible and one invisible. Not quite sure, but interesting about every triangle being a double triangle. So that was a little bit about stability and an argument for stability for as you want to parsimoniously connect things into structural units and build stability from stability, inevitably you're going to get to the tetrahedron. Okay, and then the last sections to look through today are 630 to 633. All right, so 630. Anti-tetrahedron. What a cool word. 1. Minimum of 4 points. 2. We cannot produce constructively and operationally a real experience augmenting omnidirectional system with less than 4 points. A 4th point cannot be in the plane approximately located, i.e. described by the first 3 points, for the points have no dimension and are unoccupiable, as is also the plane they describe. Quote, It takes 3 points to define a plane. The fourth point, which is not in the plane of the first three, inherently produces a tetrahedron having insideness and outsideness corresponding with the reality of operational experience. Pretty cool. So again, two things can't coexist. Everything is lines taking up space and time. So two things can't coexist. And then we thought about the graphene. Like if you had 3 points defining the sheet of graphene, you can't have the fourth point in where there's already something. So it has to be somewhere up or down around that plane, relative to that plane. So when that fourth point comes into existence or relation, it must make a tet. Before that, there's no inside and outside. But once you have the fourth point relative to the three, you have the tet. And that's corresponding to the reality of operational experience. 3. The tetrahedron has 4 unique planes described by the 4 possible relationships of its 4 vertexes and the 6 edges interconnecting them. In a regular tetrahedron, all the faces and all the edges are assumed to be approximately identical. So on average, if you have 4 equal or indistinguishable units, then they're going to come into a symmetrical relationship is supposed here, and then regular is like this one. They all kind of are. 632. So that's, I wondered if there was some other information related here about, okay, what is the anti-tetrahedron? So could that be related to the positive and negative triangle that was in the previous section? But this next section is going to perhaps get at what the anti-tetrahedron is. And it's going to relate to that phasic, the high tide and low tide. 632, dynamic symmetry of the tetrahedron. 1. There is a symmetry of the tetrahedron, but it is inherently 4-dimensional and related to the 4 planes and the 4 axes projected perpendicularly to those planes from their respective subtending vertexes. So the vertex and the side that it subtends is the side that it sweeps out. But the tetrahedron lacks 3-dimensional symmetry due to the fact that the subtending vertex is only on one side of the triangular plane, and due to the fact that the center of gravity of the tetrahedron is always only 1/4 of its altitude, irrespective of the seeming asymmetry of the tetrahedron. So there's 2 features here, that you have to violate the plane and go into another spatial dimension, kind of, to make the 4 events. And then when that happens, you lose the ability to have just the same kind of symmetry that was possible on a flatter surface or under the lower dimensional system. And then the center of gravity being a quarter up of a quarter of the altitude. Interesting. Wonder what that means. The center of gravity maybe is always inside the tetrahedron. I'm not sure if it is. Seems like it probably could be. Okay, 2. The dynamic symmetry of the tetrahedron involves the inward projection of 4 geodesic connectors, with the center of area of the triangular face opposite each vertex of the tetrahedron, regular or maxi asymmetrical, which 4 vertex to opposite triangle geodesic connectors will all pass through the center of gravity of the tetrahedron, regular, mini, or maxi asymmetric, and the extension of those geodesics thereafter through the 4 centers of gravity of those 4 triangular planes, outwardly from the tetrahedra to 4 new vertexes equidistantly outwardly from the 3 corners of their respective 4 basal triangular facet planes of the original tetrahedron. The 4 exterior vertexes are equidistant outwardly from the original tetrahedron, a distance equal to the interior distances between the centers of gravity of the original tetrahedron's 4 faces and their inwardly subtending vertexes. This produces 4 regular tetrahedra outwardly from the 4 faces of the basic tetrahedra and triple bonded to the original tetrahedra. So triple bonded is 2 tets that are face to face. They share 3 edges. The operation that's being described here is taking the tet and then inverting it so that the same one plane doesn't move, but then the point moves through the plane so that it's equidistantly on the other side. So if you do that for the regular 1 frequency tetrahedron, you flip out each side and you're going to get another tetrahedron. That is kind of why it packs this way. So that is going to result in an expansion of a larger shape. 3. We have turned the tetrahedron inside out in 4 different directions. So each holding A, B, and C constant, and then flipping D, and then going back, and then holding other one constant and flipping C. And we have turned the tetrahedron inside out in 4 different directions, and each one of the 4 are dimensionally similar. This means that each of the 4 planes of the tetrahedra faces produces 4 new points external to the original tetrahedron, and 4 similar tetrahedra are produced outwardly from the 4 faces of the original tetrahedron. These 4 external points, if interconnected, produce one large tetrahedron whose 6 edges lie outside the 4 externalized tetrahedra's 12 external edges. Pretty interesting. Another nice feature of tetrahedrons. They have a symmetry that pushes out one level in the negation, or the contrary, whichever one, of itself. So it has its own larger form, and maybe even implicitly a smaller form too. 633. As we have already discovered in the vector equilibrium, section 480, each tetrahedron has its negative tetrahedron produced through its interior apex rather than through its outer triangular base. In the vector equilibrium, each tetrahedron has its negative tetrahedron corresponding in dynamic symmetry to its 4-triangled, 4-vertexed, 4-fold symmetry requirement, and all 8 4 positive and 4 negative tetrahedra are clearly present in the vector equilibrium. Their vertexes are congruent at the sector of the vector equilibrium. Each of the tetrahedra has one internal edge circumferentially congruent with the other tetrahedra's edge, and each of the tetrahedra's 3 internal edges is thus double bonded circumferentially with 3 other tetrahedra, making a 4-fold cluster in each hemisphere. This exactly balances a similarly bonded 4-fold cluster in its opposite hemisphere, which is double bonded to their hemisphere's 4-fold cluster by 6 circumferentially double bonded internal edges. Because there are 4 equatorial planes of symmetry of the vector equilibrium, there are 4 different sets of the 4-fold tetrahedral clusters that can be differentiated one from the others. So some of this would be cool to build out or compare a little bit more visually with the vector equilibrium. The 4-foldness, of course, is interesting, and the alternating, the complementarity, the positive and negative coming into existence with the vector equilibrium. So that's kind of a nexus, and I just wonder, is there a way to do a search by shape and figure out all the relationships of the VE to other shapes? 2. Each of the 8 tetrahedra symmetrically surrounding the nucleus of the vector equilibrium. Vector equilibrium is just where you have 12 edges equally arranged. It's the close packing vector distribution. Each of the 8 tetrahedra symmetrically surrounding the nucleus of the vector equilibrium can serve as a nuclear domain energy valve, and each can accommodate 15 alternate intercouplings and 3 types of message contents. Wherefore the vector equilibrium cosmic nucleus system can accommodate 4 multiplied by 45 equals 180 positive, and 4 times 45 equals 180 negative, uniquely different energy or information transactions at 4 frequency levels each. We may now identify A, the 4 positive to negative to positive, triangular intershuttling transformings within each cube of the 8 corner cubes of the 2 frequency cube. See section 462. With B, the 360 nuclear tetrahedral information valvings as being cooperatively concurrent functions within the same prime nuclear domain of the vector equilibrium. They indicate the means by which the electromagnetic omniradiant wave propagations are initially articulated. So, pretty dense section, so total speculation. The vector equilibrium is, the nuclei can be described with a vector equilibrium because they're either liable to implode or explode. So the stable nuclei, even the transient stably nuclei, are at a transient vector equilibrium. So that's getting at the structure of the forces around the atom. So these kinds of forces either are, if we're describing this level, or it can be modeled as if at the level that we think that we're talking with protons, neutrons, electrons, etc. Radiation, photons, but also it applies to other nuclei. So then there's going to be an identification. So an equivalence being drawn between A. The intershuttling transformings within each cube of the 8 corner cubes of the 2 frequency cube. That is basically this, and then the flip of the tet. So like the as above, so below tet, the positive and the negative tet. Those, the corners trace out a cube. That's the face-centered cubic shape. So one way to think about this is if you have the tet, the core tet, the main tet under focus, that's the positive one, then it exists oscillating with all of its alternates, and those generate a 2-frequency cube. So not just a building block, but like the 8, 2 by 2 by 2. You get the 2 by 2 by 2 cube with a volume of 3 around the oscillating tet and the anti-tet. Whichever one, I'm not sure on the differences. But you get the cube. So with the tet-centric model, we get the cube. But with the cube-centric model, you never get the clean tet. You just get pixels. And that's not how we think things are because we want them to be wave-linear. So those transformations, the 4 ways that the tet can invert and make with its anti-tet in that direction, make a cube at layer 2, the 4 ways that can happen are related to the 360 nuclear tetrahedral information valves, which are concurrent functions. So are those the, I really don't know what that part is about. It's interesting it's 360. That's almost I don't know if it maps how it does to the angles, 360 degrees in a circle. And the part that I think was, maybe it's described later or something, the 3 types of message contents. Maybe that's tension, compression, and something else. But not quite sure what that one is. Okay, well, pretty interesting. Anti-tetrahedron, symmetry through transformation, negative tetrahedron. Here's the cube and the planes of the tet, the rotating tet in the cube. 462. And then here is something that came a few times, 463. There are no straight lines, only waves resembling them. So there's a zigzag, but then it can look diagonal because the frequency is so high. But maybe for another time. So thanks for watching. Hope you liked it or found it interesting. Just let me know if you have any comments or requests for a future Synergetics live stream. Other than that, thanks for your interest. Good luck with Synergetics. Peace.